Hey guys, Mr. Yisley here. So we are on to lesson number 19 in chapter 7, all about factoring special products. And so we're going to talk about some patterns that we see. Specifically in lesson number 19, we're going to talk about the difference of two squares pattern. And this is a pattern that you'll see follows the same thing happening every single time. So on your little chart that we gave you on your notes, it gives you kind of an example. And so what you've got is you've got one term that's been squared, and then it is being subtracted by another term that's been squared. And so you can see that. The big thing is it's got to have a subtraction symbol. It can't be adding, right? It must be subtraction because, again, reminder, it is a difference of two squares, meaning subtraction. And so when we have these two terms that are both squares, we know that it's going to follow a very specific pattern, which is when we factor it out, it's going to end up as a plus b times a minus b. And of course, a and b are just placeholders for the moment. But like we see right here, x squared minus 9 is the same as x squared minus 3 squared. So we know that when we factor that, it's going to end up as x plus 3 times x minus 3. Now you may be saying, well, how do we really align to that? So we've learned about this method called the AC method. So let's actually work that problem out using the AC method. Now what you may be thinking is, well, the AC method requires three terms. We have to have a trinomial. Well, remember that middle term is always some number times x. Well, if there is no middle term, that means that that number was really a 0. So 0 times x is what made that disappear. So another way of saying x squared minus 9, or writing it, would be x squared plus 0x minus 9. So that would be an equivalent right there to x squared minus 9. It means the same thing because 0 times x just causes that to go away. And then if we use the AC method, we'd go through the steps. First, check for a greatest common factor. There's not one. Then we would multiply a times c. A, of course, in this case is 1. So we're multiplying 1 times negative 9, and we get negative 9. Then we would list out our factors. 1 times 9. 2 doesn't go in, 3 times 3, there's a double number, so end of the list as we've learned. So then we say, all right, well, which could equal 0? Well, remembering that it's negative 9, that means one of them is negative and one of them is positive. So I know that if I make one of the 3's negative and one of them positive, that's going to equal 0, so that's what I'm going to use. So then I would go split it up. So first term would come down, so x squared. Second term would split into two terms, so negative 3x plus 3x minus 9, because the negative 9 would come down as well. Then we would go into grouping, so group x squared minus 3x and positive 3x minus 9. Factor out our greatest common factor. The greatest common factor of the first one is x, and then we would be left with x times x equals x squared, and x times negative 3 equals negative 3x. Greatest common factor of the second one is positive 3. Now positive 3 times x equals positive 3x, and positive 3 times negative 3 equals negative 9. Then we see that these are the same, so x minus 3, and then bring down what's left, x plus 3. And so that's how we arrive at x minus 3 and x plus 3, because the numbers here in the middle, as you may have noticed, are the exact same, just opposite signs. And so we actually learned about the reverse of this earlier in the chapter when we were talking about FOIL method and multiplying polynomials. So this is the reverse of that, what we had learned. And so because these two things are the opposites, we actually have kind of a shortcut way to go through this and show you how to do it. So the way that we, again, recognize this is, one, we're only going to have two terms. Second, they're going to have a negative sign in between. And the third is both of them are perfect squares, right, in terms of one number times itself. So when we look at these, let's take a look at example A. Rather than going through the whole AC method, which we could, and if you just prefer to do that, you can do that, right? But for the notes, we're going to show you kind of a quicker way to do that. So when I look at example A, I say first, all right, I've only got two terms, all right? Second, they're only there's a subtraction symbol in between. So that's an indicator to me, right, that I have a potential difference of two squares. The last thing I need to know is, are both of them perfect squares? Well, x squared is obviously a perfect square because it already has this squared sign. 25 I know is also a perfect square because that means 5 times 5. So really what I have here is x times x and 5 times 5 because that equals 25. So what I can do in that case is I can then go directly into my parentheses because I know that one parentheses is going to be something plus something and the other one's going to be something plus something. So, or excuse me, not plus. That should be a minus. Got ahead of myself there. All right, so one's a positive and one's a negative there. So then all I have to do is I bring down the first term that I see, which is an x. Then I bring down the first term of the second part I see, which is a 5. For the second parenthesis, I do the same thing, but with the second term. So the second term is x, and the second term here is 5. So x plus 5, x minus 5 would be my answer. So again, we determined what each part was by breaking apart the perfect squares, and that allowed us to bring it directly in because the plus and the minus will never change. All right, so let's take a look at example B and we'll walk through that same process again. So example B, I've got 4z squared minus 1. So first, I have exactly two terms, which is what I need. Second, I notice that they are separated by a subtraction symbol, so it could be a possible difference of two squares. So the next thing I need to know, are both of them perfect squares? Well, I know that 4z squared is the product of 2z times 2z, because 4 is a perfect square and z squared is obviously a perfect square. My second one, I know 1 is a perfect square as well, because 1 times 1 equals 1. So again, to make my final things here, right, I want to make my parentheses, put a plus in the first one, second parentheses, minus in the second. For my first parentheses, I want to use the first term of each one, so I'm going to use 2z and I'm going to use 1. So 2z goes here and 1 goes there. For my second parentheses, I want to use the second term. So my 2z here and my 1 here. So 2z goes here and 1 goes here. So 2z plus 1 times 2z minus 1 is my difference of two squares when it's factored out. All right, well, I'd encourage you to try example C on your own, then check your answer with mine. So example C, x squared minus 4. So again, two terms, negative subtraction symbol in between them, possible difference of two squares. X squared is a perfect square, and 64 is also a perfect square. So x squared means x times x, 64 means 8 times 8. So again, I can immediately go into my parentheses, plus in the first one, minus in the second. Question that I get a lot of times is, does it matter if plus or minus is first or second? No, it doesn't. It's going to end up the same as long as your terms are in the right spot. My first term in each parenthesis is x. My second term in each parenthesis is 8. Because you may have noticed that the first and second terms are the exact same. The only difference of them is the signs that are in the middle. All right. Well, I'd encourage you to try example D on your own, then check your answer with mine. So example B, D, 25b squared minus 36, right? Two terms, possible difference of two squares because it's a subtraction in the middle. So then I need to decide, is 25b squared a perfect square? Well, 25 is a perfect square because it means 5 times 5, and b squared is a perfect square because it means b times b. So 5b times 5b would get me to 25b squared. 36, that is also a perfect square. That means 6 times 6. So again, parentheses would be plus and a minus. My first term of each one is going to be 5b. My second term of each one is going to be 6. And there we are, 5b plus 6 times 5b minus 6. All right, well, if you have any additional questions, please let me know. But otherwise, you should have what you need to continue on in the chapter.